Shri Gurubhyo Namaha. Welcome to our online teaching academy Ekalaiva, and I welcome you all for the physics class. This is class 9 physics. Already we have completed one lesson, and now we'll move to the next lesson where you can see the different types of force, and we are going to introduce a hero called Newton and 3 laws of Newton. So first we'll see what is force. A force is nothing but push or pull. That's very simple. So a push or pull, that you call it as force. And what are the types of force? There are various types of force, and we are going to categorize the types of force into 2 things. One is contact force, another one non-contact force. When I say contact, they should touch. Okay, suppose this is a pen. If I want to lift a pen, I have to touch the pen and take the pen. Okay, it is contact force. The same pen, if I am going to drop like this, okay, you can see I am just dropping, I am just taking my hand, okay, the pen is going to fall down. Okay, it is because of some other force acting and it is pulling downward. So what force it is? We all know it is a gravitational force, and this gravitational force is a non-contact force. So we are seeing the 2 types of force, contact and non-contact force. Types of force. First we'll see the contact force, applied force, spring force, drag force, frictional force and normal force. When I say frictional force, what is friction? An opposing force, okay, which stops the motion. That is a frictional force. Again, it should be in contact. When I roll a pen like this pen will move, keep on moving until and unless it stops with an obstruction. So it's an opposing, okay, which opposes the motion. We call it as frictional force. Whether it's a contact or non-contact, just tell me whether it's a contact or non-contact. It is moving, touching an object and stops. So it is a contact force. Next, when you take non-contact force, magnetic force. Imagine this 2 magnet, okay, these 2 magnets, when I keep apart like this, these 2 magnets will not be attracted. Okay, when I bring it closer like this, the magnet will attract. So what is that attraction between the magnet? 2 opposite poles. Opposite poles attract. Now same pole if I am going to keep, the same pole, what happened? It repels. So attraction and repulsion, again they are not in contact. So we call it as non-contact force. Next, you take it electrostatic force. Again it is about the charges. 2 charges, one is positive, another one negative. These 2 charges, when I say positive and negative, whether they are like charges or unlike charges, they are unlike charges, positive, negative. What happened? They attract. So positive and negative charges attracts. Another one, I am going to take one positive, another one positive. Both are like charges. These like charges will repel. Like how? Like poles repel, like charges repel. Unlike poles attract, unlike charges attract. Next, gravitational force. Just now we saw the gravitational force. Gravity is so strong, when you leave it, it takes the force. Okay, it takes the pen and it pulls it down. Okay. So these are the basic types of forces. One is contact force, another one non-contact force. And next, just observe this. You can see something is happening here. We call this as tug of war. So 2 dogs pulling something. Okay, who is going to win? Who is going to take it away? And one is moving forward because that force is more. The dog, which is ash in color, that force is more and it is going towards that. Okay. Just keep in mind, we'll see what it is. Here you can see again the same tug of war. In the tug of war, you can see both the group, they are in the same position. There is no movement. So something is balanced. One side you imagine it as A, another one as B. Both the force, they are same. Just we can take 10 Newton, the other side 10 Newton or 100 Newton, another 100 Newton. Both are equal and opposite force. Okay, and there is no movement. This type of force called as balanced force. And next, the other group you can see, they are falling down. Okay, and because of what? One side the force is more, other side the force is less. That is why they are falling down and they are moving towards. Actually, they are not falling down, they are moving towards the other side because that force is pulling. They may be 100 Newton and this group may be 50 Newton. The force is less, so they are moving towards the force which is high. So this type of force you call it as balanced force, another one unbalanced force. Okay, the same thing we will just see. We all know force, the force represented by the letter F, and the unit of force is N, our hero, Newton, right? And you can see the two types of force, balanced force and unbalanced force. When two or more force acting on an object equal in all direction, okay, that result in no movement, that is 300 minus 300 Newton, that is equal to 0. So the force is equal and opposite. So it is 0 and there is no movement. The net force is 0. It is very important. What is the net force of this balanced force? It is 0. And when you see your net force, this is 400 Newton and this is 300 Newton, and if you minus, you will get 100 Newton. So what's the net force here in unbalanced force? It is 100 Newton. Whether there will be a movement or there won't be any movement, there will be a movement. You can see they are pulling towards this 400 Newton because that force is more compared to the other force. So the net force is 100 Newton. Okay. Now observe this. Okay, we all know about magic, right? So there is a magic and there's science behind this magic. So I'll tell you what is that. And observe one more thing. Flicking. They are flicking the card, okay, and something kept over the card and that object is going down to the vessel, what they kept here. So again, it is also a type of magic, right? Both are like magic. It sounds like magic, but actually there is a trick behind this. And the trick is nothing but our science, okay? So here I am going to apply Newton's first law. Observe this. I'll show you the next slide. Correlate with that. One more example for you. A boy is just touching, okay? Actually first, we'll see from the beginning here. The boy will be at the rest. Okay, when he touch, what happened? He will be moving forward. And again, he will use more force. The boy will move little more forward like that. Okay, so when an object is at rest, it remains at rest. Or when the object is in motion, it will be in motion until and unless it is disturbed by an external unbalanced force. Okay, you have to use the term unbalanced force. Okay, we'll see once again. A boy is at rest, he remains at rest. Okay, and boy is in motion, he'll be in motion. Okay, but what happened when he was in rest? He was in rest. Then later he just pushed external force. The other boy, external force. He touched the boy. Because of this external unbalanced force, the other boy started to move. So we'll see the law once again. When an object is at rest, it remains at rest. Or when the object is in motion, it will be in motion unless and until it is disturbed by the external unbalanced force. Here something rest and motion we are talking, right? I'm going to use another word for that. That is nothing but inertia. This law, Newton's first law, otherwise called as law of inertia. So we'll see that. So Newton's first law, the body is at rest, it will be at rest, or in uniform motion, it will be continue until and unless it is disturbed by the external force, unbalanced force. When there is unbalanced force only, there will be a movement. Okay? So we'll see the relation, inertia relation, how it is going to be related here. Okay? The inertia, when you say inertia, the first law of motion implies that the things cannot start or stop or change the direction. They cannot start, they cannot stop, they cannot change the direction. Okay? It requires some force, I told you the force is nothing but external force. Okay? From the outside to cause, if the object is at motion, okay, when it is in motion, it should be stopped. When it is rest, it should be started. Okay? To change the direction, again it needs some external force. For all these things, some external thing it requires. That you call it as external force. But in the first beginning, what happened? It is at rest. Okay, it is in motion, and that you call it as inertia. Okay, so inertia is nothing but obstruction. Okay, at rest or it is in motion, it will be in motion. To change that, it requires some force, and that force you call it as unbalanced force. Okay, so this first law also known as law of inertia. We'll see application. Okay, there are more applications. Okay, one or two examples I'll tell you. You take a mat, okay, a mat you can take it, dust the mat and see. You can see the dust particles falling down. You are dusting only the mat. The particles are falling down. Again, it's first law of motion. The object is at rest, it will be at rest. Okay, when you disturb, what happened? The mat you are disturbing. But which object is at rest? The dust particles are at rest. It is falling down. Okay. Then next, when you shake a tree, what happened? The dry leaves falls down. And one more example you can see here. People will be wearing the seat belt. Okay. For what purpose it is? To avoid the injury. Because when there is a sudden break, they may tend to fall forward. To avoid that, they wear the seat belt. Why they tend to move forward? Again, here Newton's first law of motion. A body was at rest. Okay, when there is a change in direction or when they stop, what happened? The body tend to move. So they wear the seat belt for their protection, right? Hope you can correlate now with the previous example. Okay, what I said as magic in the beginning. Yes, so here again I'll complete with the Newton's first law. The body is at rest, okay, we are disturbing only the what? The cloth. So only the cloth moves. The other object is at rest, so it remains at rest. The same thing here. We are flicking only the cardboard. Okay, the cardboard alone will move. The other one, coin, is at rest, so it falls down in the same place, right? Next, second law. Before going to second law, I'll give you a guess. Okay, from this we are going to start our next class. Just observe this field. Okay, what is going on? A batsman hits the ball. Okay, someone going to catch the ball. Okay, and how is going to get the ball? All these things we are going to check in the next class. And there I am going to relate you with the second law of motion. To receive our online lessons, please press the subscribe button and you will receive the latest updates. Thank you.